Welcome to One Time Success, aka Diligent Tutors. Today we'll be talking about frictional force. Frictional force, or friction for simple, is the force that acts on the surface of separation of two bodies in contact and tends to oppose the motion of one of the bodies over the other. We can see that the definition simply implies that frictional force does not come into play except there is motion or tendency for motion. That is, frictional force always opposes motion. So if a body is moving to east, the frictional force will move to west, vice versa. Now, types of frictional force. We have static or limiting frictional force. Static or limiting frictional force is the frictional force that comes into play when a body begins or is about to move, slide, or at the verge of sliding. That is, the frictional force you experience before the body begins motion. Now, the second type of frictional force is sliding, kinetic, or dynamic frictional force. It's a type of frictional force that comes into play whenever a body moves with a uniform velocity over another body. So we can see that the limiting frictional force must be overcome before motion. Then the kinetic frictional force is overcome during motion. Now let's look at the characteristics of frictional force. Number one, it opposes motion. It opposes motion. Frictional force is always opposite to the direction of motion. Two, it depends on the nature of the surface in contact. The frictional force in a rough surface is different from the frictional force in a smooth surface. The frictional force between even two rough surfaces differ depending on the nature of the surface. Number three, it is independent of the area of the surface in contact. Four, it depends on the normal reaction. Sliding, kinetic, or dynamic frictional force is less than static or limiting frictional force. Next, the frictional force between two rough surfaces is always greater than the frictional force between smooth surfaces. It is proportional to the normal reaction. In other words, frictional force depends on the normal reaction. It is reduced by lubrication. That is the reason we lubricate moving parts of engine in order to reduce the frictional force between the parts. Rolling friction is less than kinetic or sliding friction, which is also less than static or limiting friction. The angle of friction is the angle between the normal reaction and the total frictional force. For smooth surfaces, frictional force is negligible, but for rough surfaces, frictional force is significant. That is, the frictional force between smooth surfaces is 0. Let's look at this example. The following are correct about friction except number one, static friction is greater than dynamic friction. That is true. Static or limiting frictional force is always greater than dynamic friction. B, frictional force between two solid surfaces opposes their relative motion. Frictional force always opposes motion. C, limiting frictional force is dependent on the area of the surfaces in contact. No, limiting frictional force is independent on the area of the surface. D, frictional force depends on the nature of the surface in contact. Yes, frictional force depends on the nature of the surface in contact. That is, the correct option is C. Now let's look at example 2. Which of the following statements is true of a particle moving with uniform velocity? Now, if a particle is moving with a uniform velocity, it means that the acceleration is 0. Acceleration is always 0 whenever the velocity is uniform, which means that the net force acting on the body is what? Is zero. Now, A, the force applied to the particle is constant. That's not true. And there is no frictional force opposing the motion. That is not true. B, the applied force and the frictional force acting on the particle cancel out so that the net force on the particle is zero. That's correct. The net force on a particle moving with a uniform velocity is zero, which means the force applied and the frictional force, they cancel out. The time rate of change of the momentum of the particle is not zero. That is not true. That's not true. The time rate of change of the momentum of the particle, which is the force, is what? Is zero. The momentum and the kinetic energy of the particle are zero because the particle is not accelerated. That is not also true. So the correct option is B. Now let's look at the law of frictional force. The law of frictional force states that the frictional force between two surfaces in contact is directly proportional to the normal reaction between the surface. So frictional force proportional to normal reaction. Now if we remove the sign of proportionality, we have to introduce what? A constant of proportionality known as the word, the coefficient of friction. Now, definition of the normal reaction. The normal reaction is the force that acts on the surface of separation between two bodies. The definition of the normal reaction depends on the orientation of the body. That is, how you define normal reaction is different from a body on a horizontal plane than compared to a body in an inclined plane. So the orientation of the body gives the definition of the normal reaction. Another important point to note is that the normal reaction depends on the total mass acting on the surface. If you look at, for example, this body with the orange color, I guess that color is orange. Now, if you look at the normal reaction, R1 depends on mass 1 only, whereas R2 acting on the red surface depend on the total mass on the surface, which is what? M1 plus M2. Take note that normal reaction depend on the total mass acting on the surface. If you look at the second body, you will discover that it's just one mass resting what? On the surface. So the normal reaction will just depend on that mass. Now, let's look at normal reaction of a body on a horizontal plane with a force parallel to the plane. Now, look at the things we are dealing with. If you look here, you will discover this is the force. The force is parallel to the plane. Then, the frictional force opposes what? Motion. So, this is the type of orientation we are dealing with in this case, normal reaction of a body on a horizontal plane. Now let's move on. Let's look at conditions for calculation. Let's say we have a force that is parallel to the plane, a force that is parallel to the plane, and the plane is horizontal. So if the body is about to move, slide, at the verge of sliding, or shows a tendency for motion, then because the body has not moved, just about to move, the frictional force will be equal to the force applied to the body, which is equal to mu mg. Now, if the body comes to rest, the same thing happens. For the body to come to rest, the frictional force must be equal to the force applied. If the body moves with a uniform acceleration, then we have that the force that causes motion, which is what? F, minus the force that opposes motion, which is frictional force, will be equal to the resultant force with which the body moves, which is defined as what? Ma. So these are the three conditions that is always applied for a body placed in an inclined plane. Now let's look at work done in overcoming frictional force. Now, the work done in overcoming frictional force, first, a force F is applied parallel to the plane. Frictional force opposes what? motion. So the force that moves the body is called the resultant force, which is what? The difference between the force applied minus frictional force. So that is the resultant force in that case. Now, so work done, what will be work done now? Work done will be what? Will be resultant force times the distance moved by the body. Let's look at example on that. A force of 300 Newton pulls a sledge of mass 60 kg and overcome a constant frictional force of 60 Newton. So where we have the force applied, what is the force applied? 300 Newton force is applied. And the frictional force opposing that 300 Newton is what? 60 Newton. So resultant force will be what? 300 minus 60. So the force that actually moved the body is what? 240. Now that is the resultant force. But resultant force is equal to what? Mass times what? Acceleration. So 240 equals to the mass of the body, which is 60, times the acceleration. We have 240 over 60. That will give what? Meter. That is 4 meter per second square. So the acceleration of the body is 4 meter per second square. Now let's look at another example. An object of mass 100 kg is pushed from rest over a distance of 10 meters with a force of 250 Newton, which acts against a frictional force of 70 Newton. Calculate the velocity when the push ends. Calculate the velocity when the push ends. That is, the body is coming to what? To rest. Now let's look at resultant force. The force applied, 250, is the force applied minus the frictional force. That will give us 180. From there we get our what? Acceleration. Frictional force, resultant force equals to ma. So 180 resultant force equals to 100a. From there we get our acceleration to be 1.8 meter per second square. Now note that the body is pushed from what? Rest. So the initial velocity is 0. Acceleration is 1.8. We just calculated that. The distance moved is 10 meter, and we are looking for what? The final velocity just before it comes to rest. So we have v squared equals to u squared plus 2as. Substituting the various value there, we have the final velocity to what? To be 6 meter per second. We will look at more example in our next lecture. We have to dig deep into this topic, but this is the basics of every other calculation for a body in an horizontal plane. Thank you for listening.